The surface of our planet is 71% water, a vast liquid frontier. Yet nearly all of human civilization is compressed onto the remaining landmass. We build skyward because the ground is full, but the next great expansion is not vertical, it is horizontal. This is the story of a new technological migration, a shift from solid Earth to liquid territory. We are analyzing the engineering of the top 8 floating structures ever conceived, designed to conquer the final wilderness. They are not just homes, they are prototypes for a new way of life. It all begins with one fundamental problem. How do you build a foundation on a world that refuses to stand still? If the ocean is the new real estate, the most radical way to claim it is to sleep right under the water. Dubai started with an intimate scale. This is the Floating Seahorse, a 3-level villa spanning 371 square meters, where the foundation is not rock, but the raw physics of the sea. Sunlight pierces the surface, its rays diffusing into a soft blue glow. The descent goes past the social deck down into the structure's core, a master bedroom fully submerged in the Persian Gulf. Here, the engineering challenge is immense. Water pressure relentlessly crushes every surface, a constant siege measured in tons per square meter. The absolute silence is palpable. Outside, a parrotfish glides by in perfect focus. All motion, zero sound. Survival depends on one material, military-grade glass. This isn't just about strength, it's about perception. The acrylic panels have a refractive index engineered to be 1.33, the exact same value as seawater. The result is an optical illusion. The boundary between the room and the ocean dissolves. No distortion, no reflection, just life. But this fortress of transparent polymer is not an invasion. It is a sanctuary. Anchored to the structure are over 60 square meters of artificial coral gardens, a scaffold for new life. They are specifically designed to restore the local population of endangered seahorses, turning a private residence into a functional biological observatory. The project uses brute force engineering to protect one of nature's most fragile creatures. While Dubai builds heavy, stationary bunkers on the seabed, French engineers have taken the path of absolute lightness and the physics of surface tension. They created the Anthoniapod, a structure whose circular form is not an aesthetic choice, but a masterclass in hydrodynamics. A traditional hull fights the sea, cutting through waves and absorbing immense stress. This design does the opposite. Based on the principle of surface tension that holds a water droplet together, its spherical shape allows it to glide over the surface of the water. Instead of crashing into a wave, the pod rides up and over it, dispersing the energy of the impact across its entire curved surface. No resistance, just flow. This 50 square meter capsule is entirely self-sufficient. Its power comes from a curved photovoltaic dome, a skin of high-efficiency solar panels capturing energy from every angle. The system generates 101% of the pod's energy needs, more power than it consumes. For anchoring, it uses a sand screw anchor that twists into the seabed with minimal disruption, allowing it to inhabit protected areas where traditional vessels are forbidden. It secures its position, opens its dome, and begins to draw power from the sun. Autonomy on 50 square meters is impressive, but Portuguese engineers solved a far greater logistical nightmare. How do you ship an entire house to another continent? The answer is not architecture, it's mathematics. The float-wing house is designed around a single brutal constraint, the dimensions of a standard cargo container. Every structural component, from the floor sections to the roof panels, is calculated with millimeter precision to be disassembled. This transforms a home into a logistical puzzle, where all the pieces fit perfectly within the steel walls of just 2 shipping containers. This isn't real estate, it's a globally mobile gadget. It can be loaded onto a truck, placed on a cargo ship, and reassembled in a new country, on a new body of water. Once constructed, its triple-layer glass provides the necessary thermal and acoustic insulation, creating a stable indoor climate. But its true freedom is technical independence. Equipped with photovoltaic panels and a compact wastewater treatment plant, the structure operates completely off-grid. No power lines, no water mains, total self-sufficiency for a minimum of 7 days. Moving a house to the tropics is a logistics task, but to survive where water turns into crushing ice, an entirely different order of architecture was required. This is Villa Helmi, Finland. From a distance, it appears as a simple, minimalist cube, but its design is a direct response to the brutal physics of a northern winter. The primary challenge is not water, it is ice. The standard solution, heavy concrete pontoons, is replaced by advanced engineering. The structure floats on a foundation of composite materials, the same lightweight, ultra-rigid technology found in high-speed boat hulls and aviation. This is how a 200-ton villa maintains a perfect waterline. It's a beast of structural resistance. But floating is only half the battle. The true victory is thermodynamic. The lake freezes solid around the house, locking it in place as temperatures plummet. Yet the thermal envelope of Villa Helmi is so effective its insulation coefficient exceeds that of many high-end homes built on land. Every watt of heat is hermetically sealed inside. It isn't a summer cottage. It is a year-round residence built to face a frozen apocalypse. A warm, living structure inside a world of white silence. Ice is a brutal enemy, but the open ocean demands solutions that don't just resist nature, but deceive its laws of gravity. This is the Sea Pod. It appears to have landed from a distant galaxy, a sterile white structure suspended over Panamanian waters. The entire home hangs 3 meters above the surface, a surreal vision of luxury floating in the air. The obvious question is simple: how does a tall structure like this not tip over in the middle of the sea? The answer lies in applied physics. An immense steel spar plunges deep into the water, its core filled with air to provide massive upward buoyancy. Strategic weighting pulls the center of gravity far below the waves, creating stability through the same principle as an iceberg. The vast majority of its mass is hidden. Its futuristic curves are not just aesthetic. The aerodynamic facade is engineered to make storm winds slide smoothly around the structure, not strike it. The result is an uncanny stillness. Inside, the floor feels monolithic, unmoving, even as the ocean churns below. Total stability. This structure offers 73 square meters of living space across 3.5 levels. From the outside, it is a piece of science fiction architecture. But what if its primary function isn't housing, but healing? The submerged spar is engineered to act as an artificial reef, attracting marine life and providing a scaffold for coral regeneration. It's a habitat designed not to conquer the ocean, but to serve it. Cheating the wind is smart, but when a Category 4 hurricane hits Miami, you don't get clever. You physically lift 400 tons above the catastrophe. As the storm surge builds, a wall of water on the horizon, the transformation begins. 4 massive hydraulic legs, or spuds, deploy from the hull, plunging towards the seafloor. They anchor themselves up to 6 meters into the seabed, finding purchase. Then, with a deep mechanical groan that vibrates through the structure, the entire machine starts to rise. The system hoists a weight equivalent to 10 fully loaded semi-trucks clear of the ocean's surface. Total weight, 400 tons. This creates an air gap, completely isolating the habitat from the violent waves below. It's an engineering solution designed to withstand wind speeds of up to 250 kilometers per hour, Category 4. The principle is borrowed not from naval architecture, but from offshore oil platforms built to survive the world's most violent seas. In minutes, the vessel ceases to be a ship. It becomes a fortress. The legs lock into their final position, holding the platform static above the chaos. The machine braces for impact. While billionaires build 400-ton private bunkers, in Copenhagen, this same marine engineering has been scaled to address a global crisis. The solution began with a simple box. The standard shipping container transformed from industrial waste into the structural module for a new kind of community. From the air, the urban rigger is a precise triangular formation. This geometry is not for aesthetics. It creates a central courtyard, a pocket of calm shielded from the harbor's biting wind. But its true genius is invisible. A thermal imaging view reveals the process. A system of heat exchangers draws energy directly from the cold seawater, a technique known as hydrothermal heating. Outside, the piercing Scandinavian cold. Inside, controlled warmth, a radical reduction in energy consumption. The second secret is in the walls. They are insulated with a layer of aerogel, a revolutionary material first developed by NASA. It is 99.8% air, a nearly perfect insulator, thinner than a finger, yet more effective than thick panels of traditional foam. This is a replicable prototype for coastal cities suffocating from a lack of space, a macro structure built from micro components. The result is a structure that slashes heating costs by 85%. Urban systems are built for decades, but to forge a floating structure that will outlive generations in aggressive saltwater, there is only one material that reigns supreme. This is the Mansion Yacht. It is a visual anomaly, a colossal fusion of a modern villa and an industrial barge. Not a vessel of fiberglass built for speed, but a fortress of steel built for permanence. It spans 85 feet in length, offering 9,000 square feet of space, the equivalent of 3 large suburban homes combined on the water. This is the world's first yacht constructed entirely from marine-grade stainless steel. This specific alloy is infused with molybdenum, an element that creates a passive, self-repairing shield against the corrosive chemistry of the ocean. Rust simply cannot form. The hull never needs painting. The structural decay that dooms other vessels is engineered into oblivion. Where aluminum pits and fiberglass delaminates, this steel endures. Its purpose is not travel but presence. To ensure total stability, it does not use a conventional anchor. Instead, it deploys massive hydraulic spuds, steel legs that drive deep into the seabed, pinning the entire structure in place. The wind can howl, the tide can shift. The platform does not move. It is an investment in engineering that borders on the eternal. The engineered lifespan of its marine-grade steel hull is over 1,000 years. From glass bedrooms on the ocean floor to 800 square meter steel fortresses, this is the trajectory of human ambition. A technological leap from simply building on land to engineering new territory on water. To visualize this frontier, we have fused real-world documentation with advanced architectural simulations and AI-generated concepts. The line between blueprint and reality dissolves. What we have shown is not fantasy. It is the next phase of civilization rendered from physics and steel. This leads to one final question, a thought experiment. If you could live in one of these engineered worlds for 1 year with all expenses covered, which would you choose?